I'm losing my work office parking space. I mean, that's technically true, but it's because they are demolishing my work office, so there won't be a parking space there anymore. I decided with this change in circumstance, it's time to get myself a home air conditioning unit. Oh, that's not light. A number of my colleagues are curious to know how I get on with it. So, obviously, I need to science that. Now, I have built a temperature sensor before. I built a temperature logger when I first built the enclosure for my 3D printer, so I could see what the internal temperature got up to as a maximum to make sure I wasn't cooking any of my circuit boards. But really what I wanted to do with this project was to log the information to somewhere a bit more useful. I decided I was going to try and use a cloud service and log the data remotely. Using what was in my parts bin, I found a Pi Pico W, a DHT11 temperature and humidity sensor, which is from the sort of Arduino sensor kits. It's KY015. I also had this DS18B20. It's a one-wire sensor for temperature. And I connected these all up and had it polling for readings. So the next challenge was to try and get the data logging into the cloud. I investigated Adafruit.io, and they make it incredibly simple to send data up to their services. There's a firmware available called Whippersnapper, which you can flash onto the Pico and have it instantly configured, but it prefers to talk to I2C devices. So I ordered this inexpensive AH20 temperature and humidity sensors, which is an I2C device with the Stemma QT connector. The Pi Pico doesn't have a Stemma QT connection, but you can buy this shim from Adafruit, the prototyping Pi cowbell or Pico bell. Pin 0 on this is there, so it goes on that way around. So I believe one plugs in there, and you have to push slightly harder than I'm comfortable with to engage it. Oh, there we go. That should be complete. So now the sensor is connected to the Pico. The Pico has been flashed with the Whippersnapper firmware and is online. So let's take a look at the cloud service. My Pico is called Daisy and it's online. It's detected by the cloud service. Here you can see I've already configured this, but you can scan the I2C bus and find the device and then connect up the new component. My new component is the AHT20, and it automatically finds the 3 available feeds, which are the humidity, temperature in Celsius and temperature in Fahrenheit. For each of the feeds you can configure names, you can configure polling rates, and these feeds show up here with individual values you can search. These feeds can be added to a dashboard, and here is my dashboard of humidity and temperature in Celsius. I'm going to edit the layout here, change the display rate from 8 hours to the last 7 days, and here we can see the problem in my office. On Wednesday evening, the relative humidity in my office reached 65.5% before I ran the air conditioning unit, which is where you see that sudden drop afterwards, bringing it down to 55%. So now I can get actual numbers for the temperature and the humidity. I may add a feed for the power consumption of my air conditioning unit when it's running. I hope to be able to figure out what's the best way of using it, what feels the most comfortable, and how economic it is. and what the best way of using it is. I'll probably do some more videos if I have some success with this. But for now, thank you for watching and stay safe.